so loud. ฮัลโหลในห้องได้ยินไหมคะได้ยินเนาะโอเคหลาย setting เหลือเกิน so I start to share the screen here now you have the first activity of the class always quiz so now you can join the quiz You can now join the quiz with the game code that shows on the screen. And I'm not sure if you see the screen or not because no one is joining the quiz just yet. Okay, here we go. Vadika. Let's start the first activity of the class always with the quiz. And the quiz today is about the Python searching. And then we will continue the class with the sorting and the last topic of the class of this class, I mean of today, also of this class because today is the last class of this course and next week it is going to be your presentation of the data project and and I'd like to the presentation next week to be online. I mean, if you come to class, please bring your headphone so that you can use the notebook computer in the room, in the class to do your presentation. And you are going to be present on your machine and then you share the screen. So again, for the presentation next week, you are free to join the class either online or on site. And if you come on site, please bring your headphone so that you can always listen to your friends. Now we have 14. Not sure how many also we have 10 participants in Zoom. Yep. Hurry up. You're 1 minute late. It's now 8:31. We have now 18 for the one who is in the class. Have you joined the quiz yet? If not, okay. So let's wait for another 5 minutes maybe. So regarding the final exam, detail will be posted. But again, I expect to have the programming code questions mean that you might have to write a code. I'm going to look for the ways that if you can do it in the Moodle exam with the safe browser again. And detail will be posted soon. But the same thing, you are allowed to bring 2 sheets of A4 papers, one with the written note and the other one, you can choose either to bring the printed note or the written note. Means that, Which one? This one? The one with our asterisk. Okay. You need friends. Or that the open house syndrome. Did you have fun? Or exhausted? One day top. You guys are so young, so you need to take a rest just one day top and then continue what you have to do.อืมได้นะ ก็เอ็มไม่ปิดนี่เอาปิดเหรอ ปิดเฉพาะสถานีศูนย์สิริกิติ์อ่ะแค่นั้น ไม่คือหมายถึงว่าเขาไม่ให้เข้าออกสถานีนั้น แต่ว่ามันก็วิ่งผ่านได้ปกติเขาจะไม่จอดไงเออ ก็ไม่ได้ใช่ ถ้าคนที่อยู่สถานีสิริกิติ์ก็ต้องขยับไปขึ้นสถานีรอบข้างอ่ะฮะก็ก็จริงๆก็ไปขึ้นสถานีก่อนหน้าคลองเตยก็ได้ ใช่ ไม่อโศกคือที่สถานีอื่นขึ้นได้หมด ยกเว้นสิริกิติ์ห้ามขึ้นลงแค่นั้นเอง เพราะฉะนั้นจริงๆเราเดินทางก็ได้นะช่วงเอเปกเพียงแต่ว่า ถ้าถนนอาจจะรถติดเพราะมันปิดถนนบ่อยอย่างเงี้ยเออ ไม่หมายถึงว่าถ้าจะเดินทางไปที่อื่นอะไรเงี้ยก็เดินทาง MRT ได้เกือบปกติอ่ะอโศกเห็นบอกว่าต้องมีบัตรผ่านนะต้องมีหมายถึงว่าถ้ารถผ่านถ้ารถวิ่งผ่านแยกอะวินมอเตอร์ไซค์เหรอไม่แน่ใจว่ะเพราะว่าเห็นมันมีประกาศมาบอกว่าถ้าจะผ่านแยกอะต้องมีบัตรฮะมาวินวันนี้ยังปกติอ๋อมาวินทุกวันพรุ่งนี้ไงแต่พรุ่งนี้มันหยุดเอปิกมีเรียนเหรอวันนี้ปกติ เพราะวันนี้เขาเริ่มพรุ่งนี้เที่ยงคืนคือเริ่มวันนี้เที่ยงคืนเอเปกเริ่มตั้งแต่พรุ่งนี้นะหยุดหยุดพุธพฤหัสศุกร์มาเรียนเหรอมีเรียนออนไลน์ไหมเหรออ๋อ ก็เดินทางได้เกือบปกติ แต่ว่าวินมอเตอร์ไซค์ไม่แน่ใจว่ะว่าเขาจะยังไงอะไรนะใช่ถ้า MRT ปกติ แต่ถ้าใครวิ่งวินอย่างเงี้ยคือนอกจากไม่รู้เข้าออกได้แล้วเนี่ยรถจะติดด้วยคือวินมันก็ล้อได้แต่มันคงติดกว่าปกติอ่ะเพราะว่าเขาปิดถนนบ่อยอืมเอ็มอ่ะชัวร์กว่าช่วงเอเปกนะเออถ้า BTS นะปกติลง BTS แล้วมาไงต่อเดินไหม now we have 27 so the guys that just came no we have now in this quiz 15 เอา8:40โอเคโอเค two more minutes yeah usually we have around 40 right and now we only have 27 and someone still walking in so hurry up join the quiz and Taklanai I saw your name already yeah eventually eventually 28 who has not joined the quiz you have one more minute to go Otherwise, raise your hand if you are in the class. And if you are online, you can raise your hand too and tell your friends. Huh? Walakamon. Oh, that's a consequence, right? So anyone left here in the class that still has not joined the quiz? No? Okay, shall we start now? Yep. Let's go. The first one.
Wait.
Huh? Too late.
ตอบพี่อะไรวะ อุ้ย
Should I? Okay. No, everyone should know who is. Maybe someone asked the good questions, then I will miss it if I don't turn it on. If a list of items is in random order, means that you have to use linear search. And it is the only choice possible here, because in binary search, the data has to be sorted before you can do the search. All right, so let's go to the next question. How many comparisons would linear search take to find the index of value 7 in the list? What is linear search? And then, how can you make a comparison? Oh, if you want to search for the value of 7, then if you start from the beginning, you are going to do 4 comparisons. The first one is to compare with the first element in the list, which is 12. And then you are going to compare with 4. And if it's not equal, move on, go to 3. And then again, it is not equal. And then you move on to 7. And you stop here because you already find that the index of 7 is, the index of 7 is 3. The first index is 0, right? So, and then finally you have to do 4 comparisons to get the index of 7 in return, which the return would be 3. Okay, next question. How many comparisons you need? Then if you begin from the first again, you are doing comparisons with 1 and it's not equal, move on to 3. And again, it is not equal, move on to 5 and to 6, to 8 and to 9. And here that you already done 6 comparisons, you are finding that the value you are searching for is match. And if it is a match, then you return the index, which is now the index of, now the linear search would return the index of 5 for the value of 9, right? And the answer is 6 because it is asking about the comparisons made binary search. If the number is not in the list, yes. Now you have 7 elements, right? So the first one of the binary search, you start with the index of, you start right in the middle for binary search, right? Right in the middle is the index of 3, which is the value of 6. Then again, the search number is not in the list. You have to move on, either left or right. If you move to right, then you go to the middle of the right part, which is the index of 6. You start with 5, sorry. You start with an index of 6, which is number 6. Then you move on to the right part, which is number 9. This is the first search item. And if you move on to the right part, then you go to 9, which is the second search element. Then again, the value that you are searching for, if it's not here, then you have to move either left or right. And if you move right, you are going to 12. And if 12 again, if it doesn't match, then you stop. The same thing on the left as well. If you move from 9 to 8, if it doesn't match, you also stop there. So the maximum comparisons you have to make to define, to say that the number is not in the list is only 3. In either case, it's only 3. So that is actually the good thing of linear search. You don't have to make a comparison for every single element in the list. And if you do the linear search here, then the number of comparisons you have to make would be, if you do the linear search, and if the number is not in the list, then you have to make how many comparisons? How many comparisons? If this one is the linear search, huh? 6. How many items you have? This 3 comparisons is for binary search. Then the question is, if the search is linear search, then how many comparisons you need for this question? If I change this to be, if I
7.
change from binary to linear, then the number of comparisons you need to make would be 7. Which, how 7 comes? It is the total number of elements in the list. So you have 7 elements, then you have to make a comparison for 7 times, and then you know that the number is not in the list. And this is the good thing about the linear search, then, because you don't have to do all or do the comparisons for all the elements in the list. Okay, next. For not in the list of, I hope all of you get it right. Okay. So 4 is obviously in the list, then not in is a command in Python which will return either true or false, depending on the element you are looking for is in the collection or not. And 4 is actually in. So if the statement is for not in, then the return would be false. What is the result of list.index O? So index is the name of the method called on the list, and the return of this method would be the index of search key. You are searching for the value of 4 in the list, and then number 4 in the list, there are 2 here and here. Then the index method return the first index of that search key. That's why it's only return 1. And that's why it's only return 1. If you wanted to return this one, then you have to specify the starting index to search for, which you can place with the comma after the search key, and then you say start from the index 2, and that's how you can begin to the search index from index 2. So without any defined starting point, then the default would be start from 0 and then return the first index of that search key. Did you read the slide? Okay, so half, that's a good question. I mean, any of you also guess that's either true or false, so 50-50. Linear search algorithm does not require that the data to be either sorted or unsorted. Linear search can perform on both data that is sorted, and linear search can also perform on data that is unsorted as well. So there is no requirement of sorting or not sorting on the data that linear search perform on. So this one is false. So binary search actually require the opposite. Binary search require the opposite. Binary search require that the data to be sorted. Binary search require that the data to be sorted, and it cannot perform on unsorted data. This is the best case scenario in linear search. The best case scenario here, it is in terms of the runtime. The best case scenario here refers to the runtime. So the item being searched for is at the start of the list, meaning that you only need to make just one comparison, and then you get the return of the index. And usually when we analyze the runtime of the code or the algorithms, then we do three things. The first thing is the best case scenario. The second thing is the worst case scenario, which in linear search you need n comparisons. And the last thing that we do is the average case scenario, when we take all the cases and then take the average runtime. And with that, the base case for linear and binary are the same. You only need one comparison, but the difference between linear and binary search is on worst case analysis and also the average case analysis as well, where the linear search requires n for the worst case analysis, but the binary search would require log n base 2 for the worst case analysis. And you are going to see these topics again in the algorithms in the algorithm course next semester. Linear search is faster than binary search. And again, this is the very vague statement that you are going to make because it always depends on case by case. In the base case analysis, linear search found the first element and then stop. In the base case analysis for binary as well, you found the match on the first time of searching and then you stop. So you cannot say that linear search is faster. It always depends on the case by case basis. But if the question becomes more specific, like the worst case of the linear search is always slower than the worst case of binary search, then that's the true statement. And now it's becoming more specific, saying that on the average. On the average means you take the runtime of all the cases and then take the average. This is the question that are more about the algorithms rather than the coding, but just give you the one step in advance. So on average, meaning that you take the runtime of all the cases and then find the average value, then binary search is always faster. Because in the binary search, you need log n. And in the linear search, you need n in the worst case, and in the best case is 1. So the average of binary search is better than the average case of the linear search. And now we are talking about the dig data type that has a key and value. And then the algorithms has to find the memory address to store the pair of key and value. And so these are unrelated topics. You have the compression function plus with the hash code function And in fact, you do the hash code first, and then you do the compression, and then you get to the hash function. And that's how you are going to find the index or the memory address of that key and value. And when this process doing the different keys and then return the same number, means that the same the two pairs of key and value that fall into the same bin would have to be rearranged so that it can stay in different place of the memory. And this is actually called the collision. So collision is, in fact, the event that the return of the hash function are the same for different key. The return of the hash function are the same for different key. And the hash function is the result of hash code function followed by compression function. Which is the Python built-in data type that store item using a hash function. So that's the data type. In Python, hash table is not the built-in data type. So in Python big data type, they use the linear probing technique. They use the linear probing technique to resolve for the collision that happens. And that's a good thing of big data type. You can search for the item quickly using the big data type, because in hash table, if there is no collision, every single search key would just take one comparison to get the value in return. That's it for the quiz on sorting. And now we have the winner. Oh, yeah, the first, still the first. and now we are going to have 10-minute break, and let's come back on 9:15. เมื่อวานมาเห็นไหมฮะวันนี้ไม่รู้ค่ะไม่ได้เช็ควันนี้ไม่เช็ควันนี้ไม่เช็ควันนี้ไม่เช็ควันนี้วันฮาโลวีนฮะไม่มีแก้ฮะอันไหนใช่ไม่มีแก้ก็คือ remove เอาก็เดี๋ยว remove น่าจะ3มั้งน่าจะได้ remove 3จะได้เฉลี่ยแล้วเท่ากัน Come back, come back, come back. Come back, it's time. 5 minutes. What are you doing? There are some discussions going on in the class, so they need 5 more minutes. What announcements are being made? That people are so excited there. Come back, come back. Time, guys. Time. Time's up. We have to continue what we are doing. Otherwise, we won't finish by 12:30. All right. So last week we talked about the searching, which is the process of finding the location of the target. So you have the list of the object or the collection of the object. It can be also the tuple and the string. And then you want to know the location or the index of the object that you are looking for. Then what you can do if you use linear search, then the good thing is you don't have to sort the data before doing the search. But the bad thing is then you get the worst case runtime O of n. Means that if you have the million elements in your list or in your collection, and then you might have to look over these million items to find out that it might not be there, or it could be at the very end of your search and then you find a match. And so the runtime for the linear search is very bad. You have to look virtually every single element until you find the things that you are looking for. You can do it better by using the binary search, that you don't have to virtually look all the elements in your collection, because the search space, when you look for the value, gonna be reduced by half for every single comparison you made. So for the million item, you may probably need 21, 22 comparisons. And then you are going to find out the location, or you are going to find out that the value you are searching for might not be there. But then the worst case runtime reduce from log n or from n to log n base 2, which could reduce from a million 10 to the power 6 if you have million item, to if you take the log base 2 of 10 to the power 6, you get 20. And that's the reduction of the comparison you made. So the number of items that is very, very high, then binary search is obviously the better choice. But the sacrifice that you have to make is that you have to sort the data before using. You have to sort the data before using, and that's the binary search. And last thing we learned last time is a hash table. The good thing about the hash table is that if there is no collision, you don't have to make any comparison. You can always find the location of the object you are looking for, because that location is determined by the hash function. So if you want to retrieve the object, you get the value, you get the key that you want to retrieve, then you hash the key, you get the location, and that's the hash table. So hash table can work for unsorted and sorted data. And the limitation of the hash table is you cannot do the approximate search. The approximate search is that the key is not exactly matched with the key of the object you are looking for, but it's just close enough. And with that approximate match, the only solution you can do is the binary search. Because binary search data is already sorted. And if you want to find the closest, the value that is closest to the key you are searching for, then you can always do that with the binary search. And again, when you do the binary search, you need the data to be sorted first. So today we are going to talk about the sorting algorithms that can be used in conjunction with the binary search here. And how do I go to the next slide? Okay. Okay. So sorting means that you are going to swap the element that are not in the order to make it in order. So say you have how many people here? In the picture you have 10. And how can you make these 10 people stand in order of the height, let's say? What can you do? I mean, you all have the experience of standing in queue, right? When you sing the national song 8 o'clock in the morning, then the shorter people stand in the front, the taller people stand in the back. And how can you do that? Or how can the teacher do that? Sorting the children to stand in order. How can you make this to this? From people that come in different heights, and then you somehow have to sort them and then make them stand in order. Can you think of the way to do that? What did you do? What did you do? People may have different ways of doing things. And the things that you can come up with is, compare them and then what? And then swap them. So for this two, right? For this two, this guy should be in the front, right? Because this one is shorter. And then if this one is short, you move this forward, then this one has to move backward, right? And then the same comparison has to be made again, right? And again, you are moving to the next one. This one shorter, then swap the position. And this is one of the ways to sort the data. And so if you make a comparison for the consecutive pair, then this is called bubble sort. This is called bubble sort. And in fact, there are many other sorting algorithms, like you can always do in the other way. How? Except for bubble sort, what else can you do? If you step back further, and if you step back further, then you are going to see everyone's height. Then you can look for the shortest guy. If you step back further, you can look for the shortest guy and then put the shortest guy in the front. And if this one is removed, then you can also look for the shortest guy from the rest in the group, and then move him to the next one. And if you repeat the process, doing the same thing until the end, you are going to get all the person stand in order. And this is another way of sorting called selection sort. There are other ways as well. I mean, sorting is a very important step in computer science because it is the basic operations to do other things. So searching is the fundamental operation in deleting and updating, which you use everything. I mean, in computer science, we use it everywhere. And sorting is, in fact, a fundamental operation in searching, especially when you do the search that is not the linear search. For example, if you do the binary search, you require the data to be sorted. So then sorting is important operation that to be performed before doing the effective searching. So sorting is in fact a process that organizes a collection of data. The process of that organize the collection of data in either increasing order or decreasing order of some properties. If it is the number, then it's easy to look, right? You have the number that is the smallest one go to the either front or back, depending on you are sorting in the increasing order or decreasing order. But you can always sort other data type except for the number as well. Like if you have the string, you can also sort the string. And when you sort the string, it goes by lexicographical order, meaning that the order of the alphabet is used in sorting. Then if you have the sorted list of increasing order, then letter C go before letter D, and letter D go before letter P, and go on. And if you have the word of ant, where's the ant go? If you have the word of ant, where are you going to put the ant word? Ant? Ant would go to the front or to the back?
Front.
Front. Why?
It starts with character A.
Huh?
It starts with character A, which is the
starts
first
with
alphabet of the English.
letter A. And if I have the zebra, where it goes? If I
Back.
have the zebra, you say go to the back because you say letter Z, which is the last alphabet of English character. But then the question is this case sensitive or not? So what do you think about if you count the case differently? I mean, if you want to sort the word that come in different cases, and then how the sorting gonna work for the small case and the capital case, which one go first? Capital case go first or the small case go first? Guess what? What people do?
Capital.
Capital go first because if you sort alphabetically and if it is the case sensitive, then zebra would go first. Sorry, I would say that zebra would go after ant. So zebra would go here. Why capital go first? Huh? I mean, in general, then capital case go first. But why? Why it is defined that way? It is, yes, it is the Unicode or it is the encoding format of the string character. And either Unicode or ASCII, then you have the capital letter go first and followed by the small letter. And that's the reason why if you sort it and then you consider it is the sorting with the case sensitive, then the capital letter would go before the small letter. And again, it could be the increasing order or the decreasing order. And if it is the increasing order, then the letter K A, the big A go first, followed by small B, big B, and then followed by big zebra, and then followed by small a and small b and small c. And this is the increasing order. This is the increasing order for the alphabet sorting. If it is the decreasing order, then it would be Z and then Y and then X and then followed by A and then again capital Z, capital Y, and then capital X. And then the last alphabet would be capital A. And this is the decreasing order. So you can do both increasing order and decreasing order on the string as well. Or if you don't want to start by the number or the ASCII code, you want to sort by other things, like you want to sort by the house area that is defined by the width and length of the rectangular area, then you can always do that with the definition of property here. So you can define how you are going to sort the data, and then you can do the sorting on your definition as well. So when you sort the data, then the data is more readable. It's more readable. You can always look for the data in as a collective. That is, you can better have the looks of the data. Like when you sort the, what do you sort in your data project? I see a lot of people who post to sort something, right? So because when you sort the data, then you find more insight about the data. And also with the sorted data, what you can do is you can do the search quickly and not just the exact match, but you can also do the approximate match on the sorted data as well, which if the data is not sorted, then you cannot do that. In Python, what you can do with the data to be sorted is to use a function. And there are two different functions to be used in Python sorting. One is the sorted function, and the other one is the sort method. The difference here is that sorted is the function, meaning that you can just, let's see if you have here. Yeah. If you have the list to be sorted, you put the list inside the function as the argument. Then you get the return of the sorted sequence. And again, the argument you put inside the function is not updated. So with this function call, with this sorted function call, you get original list in the original variable or the argument you put inside the function, and you get the sorted data as the return of the function call. And on the opposite, if you do the sort method, then the method has to be performed on the object. And we are going to talk about this later today in the OOP concept or object-oriented programming. So when you use the sort method, you have to refer to the variable or the object first. Here, the usage is this. You have the random list, which is the list generated earlier. You have the random list. And with this random list, you call dot sort method. You call dot sort method. And then here, you don't have to put argument, or you can also put the argument as well. And we are going to talk about this later. And with this, what you get is the variable is get updated. So meaning that if you put 2, 4, 1, and then as a list A, then you do list A dot sort. Should I go to the collab instead? Okay. Then if you have list of A equal 3, 2, 5, then if you do list A dot sort, then you print list A. List A. Then here you go. I need better internet connection. Here you get list A that is sorted. So another example, if I use sorted function, then again I have list A defined as 4 to 5, and then I am going to sort it list A using sorted function. See again, this is called the method. Refer to the object in the front of dot operation. This is called dot operation. You put the object in the front or the variable in the front, and then you put the method after the dot operation, and then list A get updated. And here is the function. The function is when you use the function, you don't have to refer to the object. So you use the function and you put the argument or the parameter inside the parentheses. And with this sorted function, I'm going to put list A inside. And here, this is the list A after using the sorted function. So where is the result of sorted? The result of sorted is actually the return of the function here. Right. So that's the difference between sorted function and dot sort method. So sorted function, you get the return. You get the sorted list as the return. But the dot sort method, the data in the front of dot operation get updated. The variable in front of the dot operation get updated. And these are the two what do I call? These are the two ways you can do to sort the data. Either use the sort method or use sorted function. And these two things are different. One is a method and the other one is the function. And guess what? In tuple or string, that you know that it is immutable. Then which one cannot be used? First one or the second one? First one or the second one cannot be used with the tuple and string. Which one? The function or the method cannot be used on the data of tuple and string. Which one? One or two? One or two. So I leave this question to you in the final exam. It's immutable. You cannot get the data updated. Immutable means that the tuple object or the string object cannot get updated. Means that this one is not possible. Means that you cannot use dot sort for the tuple and string. And if you want to sort the data in the tuple or you want to sort the data in the string, only option available is to use the sorted function. Because when you use the sorted function, then you get the sorted value in return. You get the sorted sequence in return. And these are two different things that you can do when you want to sort the sequence data in Python. And in fact, for the one that is going to do the sorting operation on data project, you can also use these two ways of doing the sorting, depending on, you know, data type you are having and what of the effect you want to have on your code. So in the sorted function, you can have up to 3 parameters. The first one, sorted, is a function. You have to put the iterable object or the sequence object as the input of the function, and this is required. This is required. Like I am using the sorted function here, then I have to put the things, the sequence object that I want to sort inside the function. And the other thing you can do is to put the key. To put the key. Where the key here is the function name that you want to be called and get the return value of that as a starting key. Get the return value of that as a starting key. And the last element, which also the optional, is the reverse. So usually, I mean, what we always say that we can start in increasing order or decreasing order, right? The default is decreasing or increasing. What do you think? The default of sorting order would be increasing or decreasing. And as we also already see here, the default of reversible, the result of sorting order is decreasing or increasing. Yeah. Increasing or decreasing? The results of sorted function which store in list underscore sorted is increasing order or decreasing order? Increasing or decreasing? Increasing, right? I mean, it's very obvious that it's increasing order. So you can do it by decreasing order as well by setting the reverse. Setting the reverse. False or true, sorry. Reverse true. And here you get a sorted list in the decreasing order. Then for the key, I guess we have sample here. So for the key, then what you can do is to define some of the function. Say you have list A of tuple. Let's say we have list A of tuple. We have list of tuple, and then we want to sort this list, and this tuple are two number. 1. Then what is the key function here? Key function here, you can use it by defining the function. So I am going to define the function of what's that? Absolute function number. And then I am going to write a function definition for absolute number, which take the input as a tuple. Then this tuple this function would return the absolute of that tuple. When we have this, should I change this one too? Okay, so what is the return of sorted list here? Let's say reverse is false. Means that I want to sort the tuple in the increasing order according to the function of absolute number here. The first element to appear would be this one or this one or this one. Which one? Which one? Oh, I'm sorry. I did not complete the function here. Absolute of the difference, absolute difference. Should I just define the number? Yeah. Absolute difference. Which one would be the first? One or two or three?
2.
2 would have the absolute difference between tuple 0 and tuple 1 as 0. And for the 1, for this one, this tuple would have the absolute difference be 2. And for this one, the absolute difference would be 4. Then if we sort it by this function, the return would be we get this tuple go first. Oh, sorry, we get this tuple go first. The other would be 1, 0, index 0, sorry. And this tuple would go second, and then this tuple would go last, right? And that's how this thing works. Is it? Make sense? Can you see that? So here, the first one appears would be according as expected, right? The first one appear would be as expected. You get 0, 3, you get 2, 2 as the first item in the sorted list, because this sorted list defined by the function absolute difference as a key, and this absolute difference function take the difference of these two functions and then take the absolute value of that, and now then you can do the sorting by your own definition function. Like if you want to sort the points in 2D space and you want to sort the point by the distance to the origin, then you can define the function that return the distance to the origin of that coordinate, and then use that return of the function to be the sorted key. And you can specify whether you want to sort the object in the reverse order or not by using the argument reverse, and set the reverse as true, then you are going to sort by decreasing order. And that's how you can do the sorting with the Python function. So here is the example of sorted function. Again, in the sorted function, the original list does not get updated. But if you want a sorted list, it is the return of the function that what you can do is to store in the new variable. I mean, you can always store back into the same variable as well. You can also say that this one I want to put in number, and that's completely syntactically correct. But then you are losing the original list which has not been sorted. But if you want to keep both, create a new variable to store the sorted list, and the previous list would not be affected by this function. And that's the difference between sorted and dot sort method. Again, if you sort the string, if you sort string using the sorted function, can you do dot sort on the string? Can you do dot sort method on the string? If you have, say, letter of A, B, C, D as the string 1, then can you do string 1 dot sort? Can you do that? Can you do that? No, because string cannot get updated. But here is a difference. Here is not the string, but the list of string. Then with the list of string, you can do both. And with the value to be sorted as the string, what it does is alphabetical order. And alphabetical order, the number go first, followed by the capital letter, followed by the small letter for the case sensitive. And if there is other special character, it's always refer to the encoding that you are using. Whether to put which special character go first, then you have to look into the encoding table. Usually, this is the standard for all the encoding techniques used, or the encoding table used. Either it is the ASCII or Unicode 1, 2, 3. Then you get the number go first, and then followed by the capital, and then followed by the small letter. So if the string comes with multiple alphabet, then you go sort it from the first alphabet first, and then if the first alphabets are the same, then it is sorted by the second alphabet, and then go on, and then go on. So it is just the same thing that we saw the word in the dictionary. I'm not sure if you still use the dictionary as, I mean, the book dictionary in your in your class, like Thai to English dictionary or English to Thai, or have you used that? Sometimes, or you still know how to use it, right? And that's the same way they are sorting the words in Python as well. So the word is sorted by the first character, followed by the second character, and go on. And if the data type is incomparable, it cannot be sorted. For example, if you have the list that contains both the number and the string, then so sorting depends on just the comparison operation. If the comparison operation does not work on that element, then sorting cannot be done. And that's why you cannot sort the mix of number and string in the same sequence or in the same list. So it's not it cannot be logically defined whether you want to put the number first or you want to put the string first. And in that sense, Python did not define that the number of the other string, which one is greater or which one is lesser. And with that, if you cannot make the comparisons of the object you want to be sorted, then that sequence of object cannot be sorted. So if the data type are not comparable, then it cannot be sorted. That's it. So this is the example of sorted with the key argument that we did just now, that you can define how are you going to sort the data. Then here you can also sort the string by using len function. And with the len function, this is the built-in function on Python. You don't have to write your own definition of len function. The return of len is what? The return of len function is what? For let's say for Apple, you get the return of len function as for Apple, the return of len would be what number? Len. I'm talking about this key using len function, len. So the return of Apple for len function would be why you keep quiet? Huh? What's that? What's that? Say it again. The return of len would be what number? Huh? Return of len. Hey, guys, how are you going to do the final? This is a midterm content. Huh? You say len, you say len. And then you put inside the len function the first element of list, apple. Then the return would be len of apple. Huh? 5. Thank you. Then here, coconut, you get the return of coconut. The return of coconut. S. Coconuts. Coconut with S. The len of coconut is the number len coconut, you get which number in return? Come on, 8. Is it cocoa is 4, right? Not 3, 7. Then S, 8. The return of coconut is 8. Apricot. Apricot is 7. Strawberry. This is a complicated one. Strawberry. 10. Yeah, 10. Plum. 4. And according to the return value of key function here, which one would go first? Apple or coconut or apricot or strawberry or plum? Plum go first. This one go first. Yeah. Followed by 4 go first. Followed by 5. Which 5 is apple? Then apple here. And from 5 go to 7, apricot. Then apricot here. And then go to 8, which is the coconut here. And then strawberry 10 at last. So if this is in the final exam, can you expect what is the return of the sorted function? Yes, right? I mean, either by my definition of function or the built-in function in Python, you can do both. All right. The number of required arguments in the function passed to key must be packed into one tuple. So the function that you define cannot take more than one argument because the element in the sequence passed to the function would go one by one. So if you have the multiple value packed in a tuple and then pass it to the function that you want to define as a key to sort the data. The function used with key must be able to handle all the value in the iterable. Say you have key as the int function. Which one cause a problem here? Which one cannot be used with the int function? Which one cannot be used with the int function? the last one, right? 50, because 50, you cannot use in function with 50. So when you define the function as a key to use for sorting, then that function must be able to handle all the object in the sequence, all the object in the sequence. With the sorted function, these are the three things you can do. These are the three parameters you can do. The iterable, that the sequence data that you want to sort, the key or the function that you want to use for sorting, and the reverse parameter to specify whether you want the return of the sorting value to be the increasing order or the decreasing order. And for the dot sort method, you can virtually do almost the same thing, except that the sort method, dot sort is the method. So you have to refer to the object. So you cannot use with the tuple and string. Then you can only use with, for the built-in data type, you can also use, you can only use with list. And then there is no return for the sort method, but it modifies the value that is in the object or in the list. Again, you can also specify the key parameter as a function to be used for sorting. Also, you can set the reverse parameter to be either true or false. If it sets to be true, then it is sorting in decreasing order. Reverse true means that you are going to sort the data in decreasing order. And if it's false, then it's just by default. So by default means that you are going to sort the data in increasing order. And these are the parameter you can specify in dot sort. Are they the same as sorted function? Are they the same as sorted function? Yes, no? Yes or no? Yes, exactly the same thing, right? Except that if you have the list to be sorted, if you use sort method, you put list in front of dot. And if you use sorted function, if you use sorted function, you are going to sort it and then put list inside, followed by the key and reverse. So there are three parameters involved in using the sorting function, either sorted or sort method, where you can specify, apart from the sequence of objects you want to sort, you can also specify the key and the reverse. And for the tuple and string, if you are trying to sort, then it's going to throw you the error, because it said string has no sort attribute. Then what you can do is to use the sorted function. If you want to sort the alphabet in the string, or you want to sort the object in the tuple, you can only do sorted function. You cannot call the method sort because it is immutable. And so this is the assignment number 2 for sorting. Then you are going to write the function to be used for sorting the 3D Cartesian point given in the assignment. So the key name distance 3D is the function to compute the Euclidean distance between the origin and the specified coordinate. Euclidean distance of the point to point in 3D how to compute that, you can always look it up in the internet, right? And then you just need to validate your code by the correct results. So, which one is the closest point to origin? 0, 0, 0 here. Which one would go first? How many points we have here? How many points we have here? 7. Which one would go the first one if it started by increasing order? According to the distance of the point to the origin is at 0, 0, 0. 2, 1, 1 would go first, and followed by 1, 2, 3, right? We know for sure that this one would go first at the index 0, and this one would go second at the index 1. And the rest, you can verify that. Okay, so this is the assignment number 2. And we are going to talk more about the sorting algorithms that you can do. You can write your own. I mean, first you have to understand, then you can write your own sorting algorithms, and then it's going to link to what Python used for sorting. Python is actually use the merge, the what's that called? It's called the hybrid approach. So it is using the selection sort and merge sort together, and to define the sorted function and the sort method in Python. So how all these things work? First we go with bubble sort. Bubble sort is actually come from its name. The bubble that go to the top of the cup would be the small bubble or the big bubble. The bubble that goes to the top would be the small one or the big one. Have you ever noticed that? Me neither. But what they said is that when you pour the water in the when you pour the soda in the cup, then it creates a bubble, and this bubble would be sorted in order. So it swaps the position of the bubble by having the big one go on the top. So the big one keep going on top until reaching the most top of the cup. And then with this one, each bubble has its own way of going to the correct order. And that's the idea of the bubble sort. So in the bubble sort, what you do is to compare the two neighbor items and then swap them if they are not in the correct order. And then again, the algorithm move forward one by one. The index for the comparisons move forward one by one until the end. And guess what? When you have the original list like this, you have 2, 8, 6, 7, 3, 10. It begins from the very bottom of the cup to make the comparisons and adjust the order. So first, 2 and 8 are compared. Then, depending on whether you want to sort in the increasing order or decreasing order, then you make the correct order according to that. Here, in this example, they are sorting by increasing order. Increasing order means that the latter element has to be greater than the former element. The latter one here when you look at these two neighbor, 2 and 8, this one is a former one and this one is the latter one. So the latter one has to be greater than the former one. If this is not the case, what you do is to swap them. Swap them means that you are going to switch the position of that. You are going to move 6 to the position of 8 and then move 8 to the position of 6. And that is called swapping, right? So it begins from the first one, the first pair, 2 and 8. 2 and 8 is in the correct order or not? Yeah, increasing order. So for 2 and 8, is in the increasing order or not? Yes or no? 2 and 8. Are they correctly defined the increasing order? Yes, right? Because 8 is greater than 2. As the latter one is now 8. Is greater than the former one, which is now 2. Then this one is correct. If it is correct, then we do nothing because it's already in the correct order. Then the index, the first index for comparisons move from 0 to 1. Move from 0 to 1. Then again, you do the comparisons 8 and 6. It is in the correct order or not? 8 and 6 here is in the correct order or not? It is. Yes or no? 8 and 6. Which one should go first between 8 and 6? Which one should go first? 6. Then what we do is swap them. This one, 6. This one, 8. We swap them. How do you do the swap in code? How you do the swap in code? The easiest one is to create the buffer. So the easiest one is to create the buffer. In Python, you might not have to do that, but this will work for all. You have the A of 10, and then you have the B of 8. What you can do to swap is you define C equal to A, and then you keep A value in C, and then you take value of B in A. And then you are going to take the value of A back to B. C, and then you print A and B. This is before you do the swap, you get A and B of 10 and 8. And then after the swap, you get A and B of 8 and 10. And this is how you do the swap. You have to create the temporary variable and then use that to store the value. And again, in Python, you might not have to do that, but this is the standard way of doing the swapping in the code. And with this, after you make a swap, then you go further. You move the first index for comparisons from 0 to 1 to 2. And then again, 7 and 8. Correct order or not? 7 and 8. Do you need to swap them? Yes. Then from 7 and 8, then you are going to swap them to 8 and 7. From 8 and 7, you're going to swap to 7 and 8. And again, you move the comparisons to the next index. 8 and 3. What do you get? You have to swap them. 8 and 3. Do you need a swap? Yes. Then you got to chain 8 to 3, chain 3 to 8. Then again, you have 8 and 10, which is fine. What do you get from the first round? This is called the first round. What do you get? Can you say that the biggest one would always move to the end of the list, right? So if you can say that you can always have the biggest one move to the end of the list, then you can skip that in the next round. You can skip that in the next round. So if you do n round, then you get all the numbers sorted. And this is how bubble sorted works. So you have n minus 1 passes, and in each pass, you have to do again maximum of n comparisons. And with that, you have the bubble sort that can perform to change from unsorted data to sorted data. And with this bubble sort, then in each round, you are going to add one item to the sorted list, and that one item to the sorted list is actually moved from unsorted list to sorted list. So you move one item to the sorted list one by one, and then you do n times, then you get all n items sorted. And the first round, the largest element pop up to the top or to the last element. With this bubble sort, require n minus 1 pass to sort the data, and each of the n minus 1 pass you require at most n comparisons, and for n minus 1 pass and each pass you need n comparison, you need at top n to the power of 2 comparisons. N to the power of 2 comparisons. For bubble sort, it is slower or faster than linear search. What do you think? Searching and sorting, which task is less computationally expensive? Which one is faster in general? I mean, I would say by average, let's say. By average, which one is faster to perform? Sorting or searching? Sorting or searching is faster by average. I mean, I'm referring to bubble sort, and for searching, I'm referring to the linear search. Which one is faster to perform by average? Sorting or searching? Huh? Sorting is faster or slower? Sorting is faster or slower? Huh? Bubble sort and linear search. By average, which one is faster? Huh? Which one is faster? Huh? Linear search is faster, right? Linear search is faster. So, again, if you go back, make comparisons, linear search and binary search, which one is faster? Linear search and binary search. Binary search is faster, right? So, what if I ask, in binary search, you require sorting. In binary search, you require sorting. Then binary search is not one step, right? You begin from unsorted data. You want to do binary search, you have to first do sorting, right? So which one is better on unsorted data? Binary search or linear search? question gets more complex. Right? You first always begin from unsorted data. And if you want to search the item with the binary search, you have to do sorting first. You have to do sorting first. But if you do linear search, you don't have to do sorting. Then again, on unsorted data, binary search or linear search is faster. What is the response? Should I leave this to the final exam question? So these are all the questions you have to ask when you do the algorithms. I mean, especially when you want to do the what's that? The effective algorithms. The effective algorithms mean that the algorithm that works faster and consume less memory. I mean, without considering the output, because the algorithm to success, then you have to get the correct output. That's the first requirement. But apart from getting the correct output, you also have to consider the cost, the computational cost, which is the runtime and the memory space it is taking. So now the question is that if you begin from unsorted data, and which one would be better choice between binary search and linear search? Linear search for one search operation, right? If you search 1,000,000 times, how many sorting you have to do? If you have the data of, say, 10 million elements, and if you want to search on this data for 1,000,000 times, how many sorting you have to do if you want to do the binary search? Do you have to always resorting again and again? No, right? You just need to sort once. You just need to sort the data once. After sorting the data once, then you can always doing the delete, update, and insert operation which requires the search operations. And that's why, you know, even if sorting is expensive, but it's a fixed cost, even if sorting is expensive, but it is a fixed cost. So if it is a fixed cost, multiple times that you have to do the search, is still doing the binary search is more effective choice than doing the linear search. Even though you have to know the cost that before doing the binary search, you will have the sorting cost as well. And so for the sort code, I mean, for the example code for bubble sort in Python, you can always find it in the internet. And another type of sorting is the selection sort. Selection sort is very simple. I mean, you step backward. You step backward to look through all the data, and then you are going to find the smallest or the biggest first. Either the smallest or the biggest first. And then you put that either smallest or the biggest in the sorted list. And then again, you go back to look for the smallest in the rest of unsorted list and do the same thing over and over, and then you get the sorted list. So here, when you have the original list, the way to look for the smallest one is to make the comparison to the rest of the element, and then if the element in comparison is smaller than the first one, then you make a swap. So the comparison are not made just for the one next to each other, but for the fixed position in the first round. In each round, you fix the position for the element to be compared. In the first round, you fix at the first position, and then the first will compare with the second, the first will compare with the third, the first will compare with the fourth, and then again. Then after each round, you get the smallest one go to the front, and the same thing. In the first round, you get the first one go to the front. In the second round, you get the second smallest one go to the second. And then in the last round, you are getting what? You are getting the last one go to the last element, right? So here in the selection sort, the runtime are approximately the same as the bubble sort. It's just that the index for comparison are not next to each other. That's it. And with this selection sort, you also request n-1 pass, and in each pass, you are going to require at most n comparisons. For in total, then you are going to require at most n to the power of 2 comparisons. And similar case to the bubble sort, also similar case to the insertion sort as well. For the insertion sort is that you get the element to be sorted one by one. So from the first one, you get the first element, and then you get 4 and 7. You are going to find the position of 4. Then 4 and 7, you have to put 4 in the front and 7 follow up. Then you get the next element of 5. If you get the next element of 5, then you have the sorted list of 4 and 7. Then you have to find the position of 5. The position of 5 can be either this or this or this. The requirement is that 5 had to place at the position where it is greater than the front and less than the next one. So if you put 5 in the front, then it does not pass the test because 5 greater than 4. Then you have to move to the next one, which is 4. Okay, you put 5 here, and then you have to look at 7. If 5 less than 7, then it can be placed here. If not, then you have to move further. So the position you are going to place the item, it has to be the position where when you put the item is greater than the front and less than the next. Greater than the front and less than the next. For example, if you want to put the 8, here, so you have the sorted list of 4, 5, 7, and 9. You want to put the 8, you are going to put in between what? You want to put the 8, you are going to put in between what? The possible solution is that you go to try the first, and then again 8 and 4. You cannot put 8 here because 8 is greater than 4. Then you move forward. Okay, 8 greater than 4, but 8 is not less than 5. Then it doesn't work here. Then goes here. 8 greater than 5, true, but 8 less than 7, false. Then you cannot put here. Then you have to go further. 8 greater than 7. Yes. 8 less than 9. Yes. Then you can put here. And this is called insertion sort. This is called insertion sort. So you have to again have n round of finding the correct position of each item. And finding the correct position of each item takes at most n comparisons as well. So in these three types of sorting, we call the basic or incremental sorting algorithm, which takes n to the power 2 comparisons to sort the data. Which takes n to the power 2 comparisons to sort the data. And the more effective way of doing sorting is the merge sort. In merge sort, you are dividing. It's just very similar concept of doing the binary search. You are dividing the unsorted list into two parts. And then you are doing the sorting on each part and then make a comparison and then make a combination or merge them. So first, this one divided into two parts, you get 7, 6, 1, and then second part you get 5, 4, 3. And what you have to do is sorting this and then combine them to get the sorted list. And to sort this, you do merge sort. You do merge sort again. You have list of 3. When you do the sorting with merge sort, you divided this list to 2 parts. So one part has 2 elements and the other one has 1. And again, you have to do this. You do sorting of this one. This one, do you have to do sorting? One element, you don't have to do sorting because one element there is no, one element always be sorted. There is no comparisons to be made. So you don't have to do sorting on one. But here, when you do sorting on here, 2 elements, you again doing the same thing. Now comes to merge. You have 7 and 6. You merge them. You have to make a comparison which one go first. And then you get 6 and 7. 6 and 7 after the merging. 6 and 7 merge with 1. How do you do that? 6 and 7 merge with 1. You are getting 6. You sorted 7 and 6, you get 6 and 7. And then you are going to merge with 1. Then you are getting 1 first, right? When you do the merging, if you have 2 lines of sorted list, there you have 1, 3, 1, 21, 31. And then you have another list of 4, 17, and 18. You have 2 lists like this, and you are going to merge them. How do you do that? You know that this one is the smallest in list A, right? And also this one is the smallest in list B. Then you compare the smallest in A and in B. Which one is smaller? Go to the new list. Go to 1. Then this one remove from the list because it's go to the new list already. Then the smallest in A become 21. The smallest in B is still the same, which is 4. Which one you are going to move to here? 21 and 4. you are moving 4. And this one remove because it put in a new list. Then again, you have 21 and 17. You have 21 and 17. Which one you are going to move forward? 21 and 17. Then you can move 17 forward because it is smaller. Then what you have left for the second list is 18. And 18 and 21, you are going to move which one forward? 18, right? Then you again finish with list B. And then if you finish with list B, you can move all the rest of list A to the new list. And this is getting you the merges of two sorted lists. This is getting you the two merged lists. This one getting you a merged list of two sorted lists. And this how merge perform. And with this, here you have 7, you have 6 and 7, and you have 1. Then the smallest one, 6 and 1 get compared. Then 1 goes. Then 1 remove. You get the rest to 1, 6, 7. And that's how you get the sorted list for this. So it goes down, break the element just to 1, and then merge back. Here, 5, 3, 1, you split it to 2 parts, which you get 5 and 4, and the last one you get 3. 3, then it's done here. It's sorted. Then 5 and 4, with the sorting algorithm, you compare it. You put the smallest to the front, you get 4, 5, and 3. For 4, 5, and 3, merge back, you get 3, 4, 5 as a sorted list. And you merge 1, 6, 7 with 3, 4, 5. Again, you do the comparison of the first one, 1 and 3. Then you put smallest forward. Here, the index move to 6. And with 6 and 3, you move 3 forward. Then move the index to 4. Then you have 4 and 6. You push 4 forward. Then you have 5 and 6. With 5 and 6, you push 5 forward. Then you have 6 and 7 to be placed in sorted list. And this is the merge source. This is the merge source. How many levels we have here? How many levels we have here? From top to the bottom. If we have, say, 1 million items, let's say that just 1,000 items. With 1,000 items, how many split maximum would happen from top to the bottom? How many split with 1,000 elements? How many split? The first split we get 500 and 500, right? The second split from 500 to 50. The third one from 250 to
125.
125. Then from 125 to 64. From 64 to
32.
From 64 to 32. How many levels in total then? How many split from top to the bottom? until we reach to the case where we get one element each, and then we are going to merge them back 10 level. And that's the 10 round of merge sort. So instead of having to do 1,000 rounds, then in merge sort we do log n base 2 round. And in each round, what you have to do is the merge, which at most take n comparison. Then from n to the power of 2, in merge sort, it takes at most n log n comparisons to do the sorting. So merge sort is more effective than insertion sort, bubble sort, and selection sort, which is the 3 basic sorting algorithms. And here is the sorting time and space complexity for each sorting method. And what Python does is Python uses a team sort, which is the hybrid sorting algorithm, combining the merge sort with the insertion sort. And with this sorting algorithm, it can be done either from the first element or on the last element. So first, if I give you the code, then can you define whether the code given is which type of sorting? And second, if I ask you to modify the code to do the sorting according to the definition, say if I give you the insertion sort from the first element, then I ask you to modify the code to do the sort from the last element instead. And that could be the final exam. Okay. So here again, in question number 1 for the sorting is that you have to implement each of the sorting algorithms and again plot the runtime vs the input length curve comparisons for each of the algorithms. So the key concept of the sorting is the runtime. I mean, one of the key concepts is the runtime, and of course, also the space comparisons as well. But space could be complicated to measure, and runtime is the easier one, and it is the actually more important one now. And for each algorithm, what you have to do is you have to run 20 times because then you can take the average and as a representation of the runtime for each algorithm. Because if you just do one time of random thing, it could either give you the best case scenario or it could give you the worst case scenario, and that number is in fact not comparable. So this is also the key thing when you do the computation with the random things, then you have to do it multiple times and then they take the average value as the representation. And that's it for sorting. So both we talk about the sorting in Python, and second we talk about the sorting algorithm as well. And then now let's have 10-minute break and then come back to the last topic of this class, OOP. ว่า กยศแป๊บนึงอ๋อต้องไปที่ไหนเนี่ยปิดกัน Hello. Resume. I know everybody is exhausted. Me too. We just have to finish what we are doing. Yeah, that's right. So, are you ready? Probably 40 minutes top, let's say. Who knows, right? Yeah, I mean, so come back. Online. Can you hear me? Yes.
Yes.
Hello. Online. Can you hear me?
Yes, sir.
Yes. Thank you. So this topic is the lightweight topic. It's just about the programming concept and no more algorithms. Okay. So there is no HH or anything. It's just like what can be used, what cannot be used, and what are the approaches in writing the code. Hey. Into on. We are starting the class. Yeah, see? Now I know your name. See what's gonna happen. Huh? Yes, just a small example of writing. So the concept of OP. So usually what we are doing, I mean, most of the programming language, we are using, it is called imperative programming. So what it means by imperative programming is that you write the code to tell the CPU what to do. You write a code to tell the CPU what to do in order. In order means that for the order in Python, the statement on the top executed first and followed by the next line. And if there are multiple statements in a line, then the statement on the left executed first, followed by the latter one on the right. Then in imperative programming, you write the code to tell the CPU what to do. For example, you write a code to say that you are going to define x as the output of the arithmetic expression 16 plus 2, and that's called imperative programming. Then in imperative programming, it can be roughly defined by the approach used to write that imperative programming, either procedural language or object-oriented. As far as we did in the class, we are doing this kind of approach. We are doing procedural-oriented programming, means that we have a pool of data in the form of course, variable. We have the pool of data in the form of variable, and then we are writing the code to execute it on this data without packing the function and the data together. And if we do that, then it is another kind of programming approach called OOP. So in procedural oriented programming, we only have a pool of data and we have a pool of functions that act on the data. And all mixed up to the same thing. I mean, data that's not divided into the part that works with which function. All the data looks the same, all the functions look the same, whether it operates on which piece of data. And in OOP, here, we are going to pack the data and the function together. And then the data can be packed in pieces depending on the relevant to the function, the relevance to the function. And this one, when we pack the data to the function, then we call it object. So object is in fact just the packing of data and function together to make it easier to handle. Easier to handle in the sense that you know that this function should be worked with which data. For example, if you have the function called, let's say you write a program for the university data, then you have the function called register. Then this function, you know that it should be used to only the person that is student. Because as a faculty, I don't have to register any credit, right? Then, of course, you can pack this one as an object of class student. Meaning that this register function, or later we will call this one a method. Method is a function that bundle with the data in the object. And again, if we have the function called, what is a function that can only be used with faculty? Get paid, salary. Get paid. Then we can bundle this function together with the data of faculty or staff, sorry, or it can be staff to be more general. Or you can have the function of get paid to pack with the data of staff. And this one, the code would be easier to handle because then you can define that this function can only use with this piece of data. And that's, the organization of data and function would be easier to manage. And these are the two concepts for imperative programming, in which Python is, in fact, has been object-oriented approach since it exists. So Python is, in fact, by design, it is the OOP programming language. So for the OOP or object-oriented programming, then you bundle the property or the data and the behavior or the method into a single unit. And the container of the properties and behavior, we call it class. The class is the collection of objects, or the class is in fact the template. The template that is used to create the object. So when you have the template, you are going to say that this template would have which property or which data and which function. Say, for example, you have the class of saving. Then this saving would have the minimum balance and the rate of interest as the property of saving. Then you can create the saving account. You can create the multiple saving accounts as the object of class saving. And so the class is the collection of objects. The class is the template that is used to create the object. So the class contains the blueprint or the prototype from which the objects are being created. and it contains attribute and method. Attribute here is actually just the data or the variable. The method here is actually just a function, but defined on just only this object, the function of object, the function of class. So the object is the entity of the class. The object is the entity of the class that has a state. A state means the value of the attribute at the time. The state means the value of the attribute at the time, or the value stored in the variable at the time. And the behavior means the method associated with it. Associated with it according to the class definition. According to the class definition. And with this, say I define the class dog. The keyword that is used to define the class is class. Small c. Small c. The class has name and definition. And with this class, what I can do is to create multiple objects of the same class. Multiple objects of the same class. Say I can create object 1 is the object of class dog. And with this object 1, I can also create another object called object 2, which is the object of the same class dog. And the object consists of name or identity, consists of state or attribute value, consists of behavior or the function of the class, or it is known as the method. So the method is in fact just a function, but it is a function defined within the class. For example, we have the class of Pokemon. Then we can create multiple Pokemon with different names, like we have name of Pikachu and with the attribute of type and health. And then we can also define the method associated with this class. The method can be attack, can be dodge, can be evolve. So, and it can be any other method depending on the function definition that you put in the class. And that's the composite of the class template to create the object. And the attribute or the variable stored in the object, the variable stored in the class and object can be divided by either it is stored as a class attribute or the object attribute. Say you have the class of student, then each student would have their object attribute as object attribute of each student would be name, parent's name, and telephone number. And what else you have as the personal information for each student? GPA, right? You might not have, so now your GPA is no or whatever. Then this is the object attribute. Then we can also set up the class attribute that share among all the objects in the same class. Let's say we have, what else we share the value? The pro GPA pro, GPA of GPA pro. Like this. What is the GPA for probation? 2 point what? 2.0, 1.75, I guess. I don't remember. Too long ago. Okay, so this GPA Pro could be the class attribute that share among all the objects. So to summary, the class attribute is the variable that share with all the objects in the same class, and the object attribute is the data for each individual object. It doesn't have to be the same. For example, the personal GPA is different from one to another object, right? But the rate for the GPA for probation is the same for all the objects. That can be the class attribute. And for other personal information, it can be the object attribute. And in Python, if you want to define the class attribute or the attribute that share among all the objects in the same class, then you are just write the class attribute after the keyword class. After the keyword class. And this attribute can be called by using dot operation. And with this calling attribute, you might or might not notice there is no enclosing parentheses because it is the attribute, not the method. If you call the attribute, you don't use the parentheses. But if you call the method or the function, then it has to be parentheses. That's why the last long time ago, there was a question about calling the value of math.py. Then you don't have to put the parentheses because math.py, pi is actually the class attribute of math class. And if you want to define the object attribute, last time when we define the class attribute, we put outside the init method. But if you want to define the object attribute, you put inside the init method here. This is the object attribute. And this one is the class attribute. Meaning that each object can have their own name, their own type, their own health, but all the object has max health 100 or the same, and all the object is created at the version 1.0.2, all the same. And that's the difference between the class object and the class attribute and the object attribute. And with this you can access again instance attribute by calling it attribute name after dot operation here. So first, then object one is created as the object of the class Pokemon. Then object one has a name, then you can print its name as object one dot name. Then you can also update its name using the same way of calling the attribute, which is you have the object one as a variable of the class, as the variable that store the object in the class, and then you have dot operation and then followed by the attribute name. And with this, you are referring to the name of object one, and then you're going to update the value to Pikachu. And then with this one, object one has a name of Pikachu, and then when you print it out, it's going to print Pikachu. That's it. And to initialize the object, then you can put the initialization code inside the function double underscore init double underscore, and inside that the input is the keyword self. The keyword self here is a reference to the current instance of the class or the object or the current object calling that function. The current object calling that function, you use the word self. So self.name means the current object, the name of the current object would be set to anonymous. The type of the current object would be set to unknown. The health of the current object would be set to 0. And the current object is from init function, means that the current object being created. When you do the instant initialization, you call the class name. This is a class name. You call the class name. Inside the class name, you can also put the argument. And with this one, with this call, with this initialization call, init function will be called. Init function will be called. And with the function call of init, then this statement inside the init function will be executed. Will be executed means that object one.name is set when it is created here. So after finish this line, after the first line finish, the name would set to anonymous, the type would set to unknown, and the health would set to 0 after the first line. And that's why in the second line, when object one.name get called, then it returns anonymous. It returns anonymous. Then this value can be updated by calling it the name of the attributes later. And with that, the object one.name has changed the value to Pikachu. Yeah. And that's how it works. First, the object has been created, then the init function will be called. With the function call of init, then the code inside the function gets executed. However, this is the difference between the, in other languages, it might call the constructor. That can be overloading. In Python, you cannot do the function overloading. The function overloading means that you use the same function name for different set of arguments, different set of input arguments. In Python, we cannot have overloading function. And when we do that, we have to init function here. The first one define, then you redefine the function. The first one gets cancelled. We redefine, when you redefine the same function name, or you reuse the function name, the same function name defined earlier will get cancelled. We get cancelled. So the call will be direct to the latest definition of the function. The latest definition of the function, where the latest definition of the function here requires one input, because cell is the object is cell, so you don't have to put in. But it also requires name underscore input. And with this call, there is no name in it, then input. Sorry, I might change this one to input. With this one, this argument is missing, so it throws the error because this one gets cancelled already. You cannot have the constructor without the argument. So in the exercise one, you just need to create a class name my class with the following attribute of the student name as the instance attribute and the class of as the class attribute, and then you are going to set the value of class attribute and instance attribute accordingly. And And apart from the attribute for the class, we can also have a method or the function. The function of the class can be divided into 3 types depending on the usage. One is the object method. The second is a class method. And the last is the static method. And the object method, of course, it is bound to just the object of each individual object. For the class method, it is bound to the class rather than the object. So, meaning that when you call the class method, you don't have to call from the object, but you can call it from the class name directly. Like when you call math.py, math is actually the class name. And pi is the class attribute. And except for math.py, you can have math.power, which is the method of power belonging to the class math. Then math.power is in fact the class method, not the object method. So the object method has to be called on the object, meaning that you have to create the object and then you call the object method. If you don't have the object, you cannot call the object method. But you can call the class method using the class object, using the class name directly. And the last one is a little bit unrelated to the class because it is the static method that is neither bound to the class or the object. It's just a general function. It's just a general function that is defined in the class, but not bound to the class or the object. And it cannot use the attribute either from the class. The static method cannot access or modify either the class state or the object state, or the class attribute or the object attribute. It can just do general stuff with, the general data that is not specified to the class or to the object. So to define a class method, we use the decorator at class method. And when we define the static method, we also use the at static method decorator in front of the function definition. Without these two decorator, it's just gonna be the default, which is the object method. So all these methods must be implemented inside the class. Otherwise, it is just a function that is implemented inside the class, then it is called method. Then whether it is going to be the object method or class method or static method, depending on whether which decorator is used in front of the definition. For example, here we have in this class, how many methods we have? How many methods we have in this class? Method is a function defined inside the class. So how many functions we have here in this class? 3. And this one, without decorator, it is the object method. And this one comes with class method decorator in the front. So this one is not the comment because it doesn't have the hash sign in the front, but it has the at symbol, at class method. Means that the function defined after this would be class method. Sorry, this is class method. And with the decorator at static method, is define the function as the static method. That's it. So the property of each method a difference in the init, which is the object method, you have to refer to self as the object attribute. And then for the class method, you are not going to refer to the object attribute, but you can only refer to the class attribute. And with the static method, you can neither refer to class attribute or object attribute. So there is no attribute associated with the static method at all. And with this, one, with a class person, then you can define the following method. And in the static method here, in the class, in the static method here, you can just do, some simple calculation that may be useful for the data in the class that is related to the class definition. Like here is a class of the person, and then I want to do the computation about the age, the birth year, and all the related term according to the age and the birth year. Then I can define the initialization as the init here to set the name and the birth year. And then for the get age function, which this one is the object class, object method, then I can refer to self, which gonna allow me to access or modify the attribute that is the object attribute. Then I can compute the age by getting the year of today minus by self dot birth year, which birth year is the object attribute. And again, I can define the function of each adult as the object method as well. For the class method, I can define get object from age that return the object of the class, like this. Object of the class can be constructed by using the keyword CLS. CLS is a keyword to create the object of the class. And again, you can create the object of the class, and you can also delete the object of the class as well using the delete method here. And with the delete method, then the code inside can be anything that you want to perform before the object has been released. The object has been released means that you are not going to have the reference to that object anymore. In Python, it's not that necessary because it has the garbage collector, which is the same mechanism in Java that is used to release the unused or unreferenced memory. There you have the list of million items stored in the class as the object attribute, and that object release then means that list, that very large list, will not be able to access anymore. And that's the job of the garbage collector to say that there is no pointer pointing to this list, then release to the system. So that the longer time you use, and then you create the chunk in the memory, and this garbage collector will have the job of cleaning the trash in the memory that is unused and return that memory space to the system. So, but if you want to do something other than that in the delete method, you can always do that in the double underscore del and double underscore, which is the delete method for the Python. And when you delete the method, when you delete the object using the del function, then it means that you can no longer access that variable. So you delete person1 means that you cannot access person1 anymore. Then it's going to, if you do that, it's going to return you the name error. So person one has been wiped out from the memory already after the delete function gets called. So meaning that the delete function is in fact associated with the delete method inside the class definition for each class. So here in the exercise 2, you are going to write a class called circle, which has the property of or the attribute of radius and color with the default value for radius and color. Then two method called get radius, get area, which is this is the object method. And then you are going to have this test case for the constructor. And then the return would be something like this. Now, object one is creating the object of class circle. Means that the class name has to be circle. And then you create a class circle with argument of the value of 2 as an argument. Then object 2 would be set radius as 2. And the color still red. Then if you set the color to blue, then the radius would be default, which is 1. And when you print all the object color and object radius, then you get something like this in return. Oh, sorry, this. Okay. This one did not get called, so you don't have to define this method. Actually, just one that gets called, which is the get area here. Here, the color here is refer to the attribute. The radius here also refer to the attribute. And the get area here is the method. What are the difference between calling the attribute or the method? Again, the color refer to the attribute. The radius also refer to the attribute. Get area here refer to the method. What are the difference between these two again? Again, how do you know that color is attribute, radius is attribute, and get area is the method? How can you know that? Here, parenthesis is with the parenthesis, you are calling the method. Without the parenthesis, you are calling the attribute. That's the difference. And again, definition of the method is a function. Definition of attribute is just a variable name. And another example of code. And that's it for the 3 exercise for OOP. So the code for programming is that first you have to solve the problem, then you write the code to solve the problem. All right. And that's the end of the class. And next week I'm going to see you present some interesting data analytics using the Python code. And the submission for the next week, except for making a presentation or delivering your finding, is that you also have to submit the presentation file and the code. You have to submit the presentation file and the code. And again, it's going to be the group submission that you are going to have to submit after the presentation. The presentation is on, what's that? On Tuesday. So then after the presentation on Tuesday, then you are going to submit by Tuesday, probably 10 p.m. Any question on presentation next week? Any questions? on the presentation next week. No? So, the reminder for this week, there are 2 assignments and 1 homework in the class of, in the lecture 13 and 14. So for 14, we just have 1 lab. And for 13, we have 1 lab and 1 homework. That's it. So 3 pieces of work that you have to submit. And the deadline is set at the Moodle. You can look it up. And what else? What else? That's it. All right. So see you next week. And again, so next week you can be online as well because the presentation will be made via Zoom. And if you have the headphone, please bring the headphone so that you can listen to your friend's presentation. Huh? Attendance, yeah. Today we don't have the attendance check because it's the last class, the Halloween. All right, so I'm going to stop share now and then stop recording.